Another day, another story. Scientists say they have made significant breakthroughs in predicting the kind of solar storms that could destroy technology on Earth. The new research will allow them to be forecasted in with better accuracy than ever before, and even before they have actually left the Sun. For decades, scientists have warned that a coronal mass ejection, or CME, could come out of the Sun and do substantial damage to our infrastructure both on Earth and above it in our satellites. While we have only seen relatively limited destruction from such space weather, researchers point to the Carrington event in 1859, a solar storm that if it arrived today could cause power and communications blackouts. Welcome to Tabo Eminent Channel. Now researchers from Aberystwyth University who presented their work at the Royal Astronomical Society's National Astronomy meeting say that their improved predictions of when such CMEs may erupt could allow us to protect that infrastructure in the case of damaging solar storms. It means that researchers will be able to predict the exact speed it is traveling at and when it will arrive. That in turn will allow for better advance warnings of when a solar storm is coming and how and when it might hit. The breakthrough came after looking at parts of the Sun called active regions, which have strong magnetic fields. It is in those that CMEs are born, and researchers watched how they changed before, during and after one erupts. They found that they could predict CMEs better by looking at the critical height of those regions, the point at which the magnetic field becomes unstable and then can spit out a CME. By measuring how the strength of the magnetic field decreases with height, we can determine this critical height, said lead researcher Harshita Gandhi, a solar physicist at Aberystwyth University. This data can then be used along with a geometric model which is used to track the true speed of CMEs in 3 dimensions, rather than just 2, which is essential for precise predictions. She added, "Our findings reveal a strong relationship between the critical height at CME onset and the true CME speed. This insight allows us to predict the CME's speed and, consequently, its arrival time on Earth, even before the CME has fully erupted." Scientists have made significant progress in predicting violent solar storms, which have the potential to disrupt technology on Earth. These advancements could lead to better preparation and mitigation strategies for the effects of solar storms on various technologies, including power grids, satellite communications, and navigation systems. Solar storms, or geomagnetic storms, are caused by the Sun's activity, such as solar flares and coronal mass ejections, CMEs. When these phenomena release large amounts of charged particles into space, they can interact with Earth's magnetic field, leading to disruptions in technological systems. Key aspects of the breakthrough include improved prediction models. Researchers have developed more accurate models that can predict the timing, intensity, and impact of solar storms. These models use data from satellites and ground-based observations to forecast solar activity and its potential effects on Earth. Advanced monitoring systems. Enhanced monitoring systems have been deployed to track solar activity in real time. These systems provide early warnings of incoming solar storms, allowing for timely responses to protect critical infrastructure. Understanding solar dynamics. Scientists have gained a better understanding of the mechanisms behind solar flares and CMEs, enabling them to identify patterns and triggers for these events. This knowledge is crucial for refining prediction models and improving accuracy. Collaboration and data sharing. International collaboration and data sharing among space agencies, research institutions, and governments have played a crucial role in advancing solar storm prediction. By pooling resources and expertise, scientists can develop more comprehensive and reliable prediction systems. Scientists achieve major breakthrough in predicting violent solar storms. Understanding the threat. Solar storms, also known as geomagnetic storms, are disturbances in Earth's magnetosphere caused by solar wind and solar energetic particles. These storms can result in significant technological disruptions, affecting everything from satellite operations to power grids. A major solar storm could cause widespread communication blackouts, GPS navigation issues, and even prolonged electrical outages. The breakthrough. A team of international scientists, leveraging data from various space missions and ground-based observatories, has developed a new predictive model that significantly enhances our ability to forecast these solar events. This breakthrough comes at a crucial time as our dependence on satellite-based technology continues to grow. Key components of the breakthrough: enhanced predictive models, AI and machine learning. Researchers have employed advanced AI and machine learning algorithms to analyze vast amounts of data from past solar storms. These algorithms identify patterns and correlations that were previously undetectable, leading to more accurate predictions. Integration of multiple data sources. The new models integrate data from multiple sources, including NASA's Solar Dynamics Observatory, the European Space Agency's Solar Orbiter, and the National Oceanic and Atmospheric Administration's NOAA space weather satellites. Advanced monitoring systems. Real-time data processing. Enhanced monitoring systems now process data in real time, providing immediate analysis of solar activity. This rapid processing is crucial for early warnings and timely interventions. Ground-based observatories. In addition to space-based instruments, a network of ground-based observatories contributes to the monitoring efforts. These observatories track the auroras and geomagnetic fluctuations caused by solar storms, offering additional data points for prediction models. Understanding solar dynamics. Magnetic field studies. Scientists have made significant progress in understanding the sun's magnetic field and its role in solar storms. They have identified key magnetic configurations and instabilities that lead to solar flares and CMEs. Solar corona insights. Detailed studies of the solar corona, the outermost layer of the sun's atmosphere, have revealed how energy builds up and is released during solar storms. International collaboration. Global data sharing. The success of this breakthrough is largely due to unprecedented levels of international collaboration. Space agencies, research institutions, and governments have established protocols for sharing data and findings, ensuring that the predictive models are based on the most comprehensive datasets available. Joint research initiatives. Collaborative research initiatives, such as the International Space Weather Initiative, ISWI, have brought together experts from around the world to focus on the common goal of improving solar storm predictions. Implications for the future. The ability to predict solar storms with greater accuracy has profound implications for protecting our technological infrastructure. Early warnings can help power companies take preemptive measures to protect the grid, satellite operators to safeguard their assets, and airlines to reroute flights to avoid communication disruptions. Conclusion. The scientific community's strides in predicting violent solar storms mark a pivotal moment in our ability to protect critical technology from space weather. Continued research and international cooperation will be essential to build on this progress and ensure that our technological advancements remain resilient in the face of nature's cosmic forces. Thanks for watching. Request you to subscribe the channel.